Okay. Now, quadratic functions, as you saw in the last two classes, there are a lot of applications involved using a quadratic functions. Whether it gives us a parabola that opens up or opens down, you may have the table on the bridge that looks like a parabola opening this way, or you can talk about shooting a basketball, and that projectile motion by your basketball would travel in this way instead. You try to shoot the basketball, the ball will go up and drop after it reached the maximum point. So there are a lot of applications involved when you are working with. Yes. So in this next example, yeah, the equation look a little bit confusing. They are using other variables. We are so used to x and y. But now they are using p and d. They are giving us an equation that would describe the relationship between the demand of a product compared to its price. And when you think about it, it makes sense when we are talking about business. The higher the price, the lower the demand. People don't want to buy it if the price is too high. And that's why we see a quadratic that opens downward. We have that relationship in this case. A parabola that will open downward. But once again, if you don't like working with these two variables, change it. Change these variables back to x and y. You don't have to stick with p and d. It would just be the same as negative x squared plus 24x plus 56. And that means we will now be using x for the price. X for the price. And then y for the demand. And as I draw it on my graph, it will be the same concept. We will have the demand on the y-axis and the price on the x-axis. Here in this question, they want us to determine the coordinates of the vertex. And as we saw on the previous page, there is a simple equation to do just that. We can calculate the x-coordinate of the vertex using the A and the B. Those are the values for A and B. 24 for B and negative 1 for A. Once you have the x-coordinate of the vertex, you can calculate the y-coordinate by substituting the number back to it. We have negative x squared plus 24 times x plus 56. And when you put it into your calculator, negative 12 squared plus 24 times 12 plus 56, that would give us the y-coordinate. And here, it gives us 200. Let's just substitute the numbers back into the equation here. Here is the equation. We have the x-coordinate, so I'll replace the x in this equation. That will give us the y value when x equals 12. So to accommodate the big numbers here, 12 and 200, I will have 50, 100, 150, and 200 on my y-axis. And here I probably will go with 2, 4, 6, 8, and 10, 12, 14, 16, 18, and 20. Once I have this, 12 and 200 will be there. I have the vertex. Does it open up or open down? Open down, negative x squared. So we expect this parabola to go this way, but don't just make a random sketch. We can make use of one more thing to go with this graph. Yes. The y-intercept. We have 56 for the y-intercept. So looking at this equation, we have the y-intercept. It happens when you substitute 0 for x, or technically by looking at the constant term in this equation. That will be the y-intercept, 56. Using this point, I can now create a parabolic shape. I can create a graph that go from here to there. And I probably will come up with a point on the other side that is approximately the same height as this. We can come up with a point that is symmetrical as the y-intercept, and they probably will drop to this point somewhere there. At this point, chapter 3, quadratic function. Most of the time we will focus our time on the vertex. And very often we will be asked to interpret the x and y value of your vertex. In these questions, we are using the x for the price, and we are using the y value to describe the demand. So in this case, I can now read this vertex as more like when the price of the product is $12, the demand of this product would then be 200. That would be, yes, that would be what it means for the vertex. The peak of the graph, yes, that means the maximum demand. The most demand at this point. And it happens when the price is 12. So when the price is $12, the demand is at its maximum at 200 units.